Welcome to ClickMyProject.com. Now we are going to discuss about the project Cross Task Mental Workload Recognition based on EEG Tensor representation and transfer learning. Now we are going to discuss about the abstract of the process. The effectiveness of EEG based cross task mental workload evaluation are still unsatisfactory because of the different EEG response patterns in different tasks, which hinders its generalization in real scenario severely. To overcome this problem, in this process we have developed the feature construction method based on the EEG tensor representation and then the transfer learning method, which was verified in various task conditions which are represented in all the data sets. At first, the original input EEG are applied to the pre-processing based on the filtering method to remove the noises from the signal. So the EEG consists of a different kind of a task and its mental conditions based on the EEG signals. So then signal is transformed into one kinds of subcategories like alpha, beta, gamma, theta and delta. So these are the subbands present in that signal. So we have to extract these subbands from this signal. At second, the features are extracted by means of the convolutional neural network algorithm, simplified as CNN algorithm. Then the classification is used to classify the signal as stress or non-stress. One of the major objective of this project is to detect the stress or non-stress. So after finding this one, the performance will be evaluated to identify the efficiency of the process. The overall accuracy will be evaluated for the classification. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the steps like input signal, pre-processing, transformation, feature extraction, classification, then finally performance estimation. These are the modules consist in this project. At first, the input signal is taken from the dataset. The dataset consists of several number of signals from the dataset. So after taking any one signal from the dataset, the pre-processing will be carried out. In this pre-processing, one of the major steps is noise removal. Hence, in this step, in case of any noises is present in the signal, it will be removed by using the filtering algorithm. After doing the filtering of noises from the signal, we just eliminate the overall sizes of the signal. In case the length of the signal is too much of long in the sense, it will be shortlisted. After doing the pre-processing, the transformation will be carried out. In this transformation, we have some of the subband transformations like alpha, beta, gamma, theta and delta. These are the subbands present in this signals. So we have to extract these subbands from this signal. After doing the transformation, the feature extraction will be carried out. In this feature extraction, we have to extract the test feature from the signal by using the peaks and convolutional neural networks, then finally time intervals. So these are the features we have to extract from this signals. So CNN is abbreviated as an convolutional neural network. So after doing the feature extraction, the test feature will be generated by using the input signal features. After extracting the features, the classification will be carried out. In this classification, we have to classify the data is the stress or non-stress by using the machine learning algorithm. After doing the classification, we have to do the performance estimation. So in this performance estimation, we have three kinds of performance like accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient. So this is the overall performance. As per this flow diagram, we have to do the process accordingly. Now we are going to discuss about the running procedure of the process. At first, open the MATLAB 2019B and then change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the user interface will be open. This is the user interface. It will be open. After that, you can see the several push buttons in the right side for the controlling purpose and then the several tables in the left side for the display purpose. First of all, we have to click the button input signal. After clicking the button input signal, the dataset will be open. In that dataset, you have to select the signal from the dataset. The collected signal will be shown in the axis 1 with the title of input signal. Now you can see the signal intervals as well as the length of the signal. The length of the signal will be indicated in the x-axis. So around 1000 values will be there in the signals. After taking the input signal, we just move to the pre-processing. So pre-processing will be carried out by using the filtering. So the filtered signal ratios will be shown here with the title of filtered signal. After doing the noise removal from the signal, we just do the transformations. Already we have discussed in the flow diagram, the transformation will be carried out like alpha, beta, gamma, theta and delta. So these are the subbands present in the signals, so we have to extract this subbands. So alpha signal, beta signal, theta, delta and gamma signal. So these signals will be extracted. Those signals values are plotted as an table here. So this represents the gamma, this one beta, then this one alpha, then theta. Likewise, similarly the delta signal will be shown here. After doing the transformation, we have to extract the features from the signals by using the CNN method. So after extracting the features, the collected features will be shown here. So in this one, CNN will be extracted, peak will be extracted, then the peak intervals will be extracted. So those three features are combined together to generate the test feature. After doing the feature extraction, we just doing the classifications. So in this classification, we have to classify whether the input signal is stress or non-stress. Before that, the classification signal ID is 1. Then we have to do the prediction. In this prediction, it will shows whether the stress or non-stress. In case of non-stress, it will shows the result as normal. After doing the prediction everything, we just move to the final stage of the project, that is the performance estimation. So in this performance estimation, we have already discussed, we have to calculate the accuracy, sensitivity and specificity. Accuracy is around 98.5%. So those values are plotted here as a table as well as in the graph value.